Now, for this section, I'll be discussing to you the mechanical configuration of industrial robots. For our introduction, industrial robotics were used for many decades now. We innovated to create more advanced and more complex design of this innovative creation to lessen work and produce more products like cars, preservative foods, tools, weapons, and mechanical parts. Industrial robotics are necessary for social economy of a country because to lessen work cost, use of human resources, and to do basic jobs more efficiently. So, what comes in mind when we talk about industrial robots? First, what are industrial robots? Industrial robots are robotic arms that can move in several directions and can be programmed to carry out many different types of tasks in different environments. These industrial robots can work in varying environments like high pressure and vacuum chambers, in clean workrooms, and in terrible dirty areas, in dangerous areas where threats of explosion, infection, radiation, or other extreme hazards are present and dangerous to humans. Industrial robots perform various tasks such as picking up and clamping activities, spot and arc welding, clamping for machining, manipulation, and transfer of parts. With the help of sensors, computer softwares, and network of complex mechanical gestures. Now, industrial robot main components. So what are the four main components of an industrial robot? Well, the main components of an industrial robot are the manipulators, the controller, the human interface device, and the power supply. The manipulators. The manipulators is the arm and can move in various different directions. On the V5 work cell, the arm moves from a V5 smart motor acting as the actuator, which provide the force to move the arm. On an industrial robot, the force can come from electric motors, air pressure and pneumatic cylinders, or fluid pressure in hydraulic cylinders. Second, the controller. The arm has a controller, which is the brain of the system. The controller holds the programming codes and receives signal from the system input, process the signal, and then sends signal out to the system output to the control robot. Third are human interface devices. So these devices are used to control robots. So one type of input may come from a human interface device, which gives command to the robot. This device can be used to program the arm and control its movement. Now, lastly, the power supply, which is the most important component of a robot. Nothing works without this. Power supply, which is where the industrial robot gets its energy for its controller and the actuator. This is typical in the form of electrical energy. Now, let's move on to application for industrial robotics. Application of an industrial robot. Handling, capable of manipulating products as diverse as car doors to eggs. Industrial robots are fast and powerful as well as dexterous and sensitive. Palletizing. Industrial robot load corrugated cartons or other packages items onto a pallet in a defined pattern. Cutting. Due to their dangerous nature, laser, plasma, and water jet cutters are frequently used with robots. Finishing. Multi-axis robots can grind, trim, fiddle, polish, and clean almost any part made in any material for consistent quality finish. Sealing and gluing. To apply sealant or glue, a robot follow a path accurately with good control over speed while maintaining a consistent bead of adhesive substrate. Spraying. Due to the volatile and hazardous nature of solvent-based paint and coating, robots are used in spray application to minimize human contact. Welding. Used for both seam, MIG, TIG, arc and laser, and spot welding, robot produce precise welds as well as control parameters such as power, wire feed gas flow. Now, types of manipulator used in industrial robots. Robot wrist. The wrist is used to orient the part or tools at work location. It consists of 2-3 compact joints. Robot manipulators are created from a sequence of link and joint combination. The link are rigid members connecting the joint or axis. The axes are movable components of the robotic manipulator that cause relative motion between adjoining links. Gantry robots. These robots are linear joints and are mounted overhead. They are also called Cartesian or rectilinear robots. Or these robots work mainly in the Cartesian plane. Next are cylindrical robots. Named for the shape of its work envelope, cylindrical anatomy of robots are fashioned from linear joints that connect to a rotary base joint. Next are polar robots. The base joint of a polar robot allows for a twisting and the joint are a combination of a rotary and linear types. The workspace created by this configuration is spherical, mainly for its design. Next are types of industrial robots. Now we're going to the part where we're going to learn what are the most common robots used for industry. First are articulated robots. Robots that have robotic limbs structured to reach object. It can freely move their robotic limbs and can do various applications that is intended to do it. Here are the followings: pick and place, welding, packaging, machine tending, assemble, palletizing, inspection, material removing, and dispensing. The robotic arms are connected to the rotary joint where each joint is called the axis. This provides the robotic arms a degree of reach and freedom of movement. The advantages of articulated robots. It can work at high speed, large work envelope for least floor space, easier to align to multiple planes. The disadvantages require dedicated robot controller, complicated programming, complicated kinematics. Now let's move on to Cartesian robots, also known as rectilinear or gantry robots, have three linear joints that are coordinated their movement in the Cartesian plane, mainly the X, Y, and the Z. This robot focuses on more coordinated command and precise result. The application for Cartesian robots are pick and place material handling, loading and unloading, CNC machine tooling, packaging automation, palletizing and depalletizing, storing and retrieving, product placement, cutting, scribing, and sorting, process to process transferring, dispensing agents, precision spot welding, part assembly, and stacking. The advantages: provides high precisional accuracy. It is in simple operation, easy to program offline, highly customizable, can handle heavy loads, and it is in less cost. The disadvantages: well, it requires a large operational and installation area, complex assembly, movement limited to only one direction at a time, which means this is a very slow process when using these kinds of industrial robots. Now let's move on to SCARI robots. SCARA robots, I am sorry, have a donut-shaped work envelope and consists of two parallel joints that provides compliance in one selected plane. The rotary shafts are positioned vertically and the end of effector attached to the arm moves horizontally. SCARA robots' applications are pick and place, packaging, assembly and inspection, and dispensing. Next, SCARA robots are lightweight and have small footprints, making them an ideal for application in crowded spaces. They are also capable of very fast cycle times. Due to their fixed swing arm design, which is an advantage in certain applications, SCARA robots are SCARA robot face a limitation when it comes to tasks that requires working around or reaching inside objects, such as fixtures, jigs, or machine tools within a work cell. The advantages: works at high speed, excellent repeatability, and large workspace. Disadvantages: requires a dedicated robot controller, limited to planar surface, hard to program offline. Next are the Delta robots, also referred as the spider robots. Use three base mounted motors to actuate control arms that position the wrist. Basic Delta robots are 3-axis unit, but 4 and 6-axis models are also available. An application for this industrial robot is as follows. The applications are less in this type of industrial robots: pick and place, assembly, and inspection. By mounting an actuator on, or very close to, the stationary base instead of at each joint, as in the case of an articulated robot, a Delta robot's arm can be very lightweight. This allows a rapid movement, which makes Delta robots ideal for every high-speed operation involving light loads. Well, to compensate its last application, this robot can work at a high speed and very accurate, as you can see in the illustration below. The advantages: work at a very high speed and high operational accuracy. The disadvantages is it is a complicated operation and require a dedicated robot controller.